All right, good morning. No. Good afternoon. Yeah. No. Good evening. Yes, welcome to another video tutorial. Glad to have you joining me for this lesson. Today's topic is factors and multiples. So get out your composition book, get out a pen, pencil. We're gonna take some notes and move right along here. Okay. So, factors, yes. You should know what factors are. You're in 6th grade, you should know. But factors are just numbers you multiply to get a product, okay? And multiples, well, multiples is the product of that factor. For example, 3. What are the multiples of 3? 3, 6, 9. Those are all products of that digit. The multiples of 3 are 3, 6, 9, 12, 15, etc. Okay? So factors and multiples, that's what we're discussing today. And what we're really going to figure out or learn or just go into is how to find the difference. How to find the difference of finding common factors and the difference in methods to finding common multiples. We're going to talk about these different methods that are available out there. So let's just talk about how to find the greatest common factor, okay? So when you are finding the greatest common factor, there's a couple methods you could use. The method that I was always taught growing up was just method 1, which was list all the factors of each and then circle the greatest pair, okay? So here, if I was thinking about 45, I would just start with the very smallest factor, which is 1, and I would go, okay, 1 times 45, and I would write this one down, okay? And then I would think about the next digit, 2. Is 45 divisible by 2? No. So then I would go to the next one, 3. Is 45 divisible by 3? And you should say yes because of the divisibility rules, right? Because 4 plus 5 is 9. So therefore that number is divisible by 3. So 3 times what? Well, you might have to actually do a little math over here on the side. You might have to divide 3 into 45. And you would get 15 after you work it out. So you write 3 times 15, and then you go to 4. Okay, apply the divisibility rules. Is 45 divisible by 4? No, so go to 5. Well, yeah, 45 is divisible by 5. 5 times what? 9. All right, see how these factors are getting closer and closer together? And then you go to 6. No, 45 can't, or 45 is not divisible by 6. 7? No. 8? No. And then you're already done because you're at 9. So the factors have now met. That's the method I have used, okay? That's kind of a long method because you're listing all of these factors for each digit or each number. And then once you've done that, then you just go, oh, well, look, I have a common factor of 1, I have a common factor of 3, I have a common factor of 15, but the greatest common factor is 15. The greatest, let's change that color, is 15. Okay. All right, so we now know the greatest common factor of those two numbers is 15, but let's try a couple other methods. Here is what's called the ladder method. Actually, let's go to method 2, prime factorization. You guys have done that, right? We've done this before. Now we've talked about how to prime factorize a number, and it's just a Christmas tree method. And so all you do is you just take 45 and you factor it. You just find two factors of 45, such as you could have used 9 times 5, but I used 3 times 15. All right, that's a prime number, so we're done with this part of the Christmas tree. It's the branches are finished, but go to 15. You can continue to factor 15 to 5 times 3. So we write that down. And now we are finished with this part because we have nothing but prime numbers, okay? 3 prime numbers. So now go to 75 and you keep factoring and factoring until you have all prime numbers. So 75, okay, we could factor 3 times 25 because think about quarters, right? How many quarters are in 75 cents? 3. Okay, and then we can factor 25 to 5 times 5. And now we are finished because we have nothing but prime numbers. And in this method, you just circle the common factors or the common prime factors of both Christmas trees and then multiply to find out the greatest common factor. I know that's confusing, but all you do is look, I have a common factor of 3 here with this one, okay? So let's write that down. And then I have a common factor of 5 with this one, so let's write that down. And that's it, because this and this, they're not common. They don't share they're not the same value, okay? So now you just multiply these two common factors from the Christmas tree, and your product is 15. It's hard to write with this. Gosh, 15, that's a funny looking 15. Okay, all right. Then the ladder method, all right? I kind of like this method. I think maybe this method might be the simplest one of the three here. But the ladder method, just write down the two digits and then make this little upside down box, all right? And then divide. Find a common factor that those two numbers are divisible by. For example, 3. So take 45 and divide by 3, and I write 15. Take 75, divide by 3, and I write 25. Okay, and now write another upside down division box and divide again. Is there a common factor between 15 and 25? Yeah, 5. 15 divided by 5, 3. 25 divided by 5 is 5. And once you cannot find a common factor between these two digits, you're done, and you circle the vertical part of the ladder and you multiply those two, and that will give you the greatest common factor, 15. Okay, so look at this, because here's what I want you to do. There's 3 methods here. What I'd like for you to do is use each method and find the greatest common factor of 18 and 54. Use each. And then what we're going to do is discuss tomorrow, which method did you like? Did you like the method that I used growing up? Or did you like the Christmas tree method? Or did you like ladder? Okay? And then what I want you to do is whichever method you preferred, use that method and find the greatest common factor of these two pairs, these two sets of numbers here. Last thing I want to just discuss is now we're going to find the lowest common multiple, okay? The lowest common multiple of a pair of numbers. Again, the method that I was taught was, hey, just write down the two digits and then just start listing multiples. Okay, so what are some multiples of 6? 6, 12, 18, 36, 42, 48. We could go on forever. Forever. That's from Sandlot. Greatest baseball movie ever. Anyway, if you haven't seen Sandlot, watch it. It's really good. But anyway, so you don't need to list all the multiples because you'll never be finished. Just list a few, and then list a few of the multiples of the other number, and then stop after you listed 5 or 6 and see if you can find a common pair. Because once you find the first pair, you're done because you're trying to find the lowest common multiple. And the lowest common multiple is 18. 18. Okay, so that method's not probably too hard. Another method is, again, the ladder method. What we used over here. Remember this method right here, the ladder? So we're going to use this method again with finding the lowest common multiple. And all you have to do, again, is just draw an upside down division box. See how I do that? And ask yourself, what's a common factor of 6 and 9? 3. Okay. So write the 3 here. And then 6 divided by 3, 2. 9 divided by 3, 3. And all you do is then multiply. Once you're done factoring, like you can no longer find a common pair of factors of these two digits, which I can't, then all you do is just multiply all of those factors. So 3 times 2 times 3 is 18. So again, GCF is 18, okay? So, all I want you to do, pick whichever method you want to use that I just showed you for LCM. Just pick whichever one and find the LCM of 8 and 12 and find the LCM of 6, 8, and 9. And the last thing I want you to do is just, in your own words, explain the difference between finding the lowest common multiple compared to finding the greatest common factor, in your own words. That is it, I believe. And I apologize, I know this video tutorial is probably our longest one yet. It was 9 minutes and 33 seconds, but I hope you learned a little bit, hope you enjoyed the video, and I will see you tomorrow.